Antipodes Island lies over 700 kilometres from the nearest point on mainland New Zealand. It takes us 3 days to arrive here on the charter vessel Tiama, a 50-foot yacht, and we travel through high seas and swells which push us all over the place. Once we arrive here, we have to find suitable anchorage from the winds, as there is no permanent place to anchor that's safe on Antipodes Island. The bay behind me, Anchorage Bay, is the best place for landing, and you can see the landing platform, which is only accessible at low tide on a calm seas day. There are times when we have to wait many days for the sea to calm before we are able to land. Once we arrive, it takes a day to carry all the gear off the boat and up to the hut at Hut Cove, where we are then based for the remainder of our trip. I'm here on Subantarctic Antipodes Island, lying over 700 kilometres southeast of New Zealand. In this joint Department of Conservation and University of Auckland expedition, we're here to estimate the impacts of proposed mouse eradication on the island's fauna. Mice were shipwrecked here over 100 years ago and have since had major impacts on the island's flora and fauna. The proposed $1 million mouse eradication campaign will remove mice from this island and restore it to its former state. But before we can do this, we have to undertake baseline scientific studies for the island's ecosystem and the potential impacts of the proposed eradication methodology. To do this, we've taken a 6-hectare study area and covered it in non-toxic biomarker bait with a substance called pyranine in it. Pyranine allows us to check which animals are consuming the bait. We've found 100% of the mice we've captured have consumed the bait, which is necessary for the eradication to be successful. We've also been working on the 4 land bird species found here, the Antipodes Island pipit, snipe, and 2 species of parakeet, the Antipodes Island parakeet and Reischek's parakeet, which are found only on this island. By hand netting as many of these birds as possible, we inspect them under UV light where the biomarker shows up, and we can see if any of them have consumed the bait, making them at risk from the eradication methodology. We've found none of these birds have consumed any of the bait at this stage, which is really encouraging that the eradication will have a minimal impact on these bird species. This is the North Plains interior of Antipodes Island, and behind me you can see Mount Galloway, the highest point. It's in this area that the majority of wandering albatross nest, and at this time of year the chicks are being fed about once a week by adults coming in from sea with food for them. It's also in this area that we've set up one of our mouse live trapping grids. Here we have 49 traps set up 10 metres apart each, and for 7 nights we capture all the mice in the area and uniquely mark them with an ear tag. These data can then be analysed using a statistical method designed in New Zealand, which estimates the number of mice per hectare, which is really important information for eradication managers. This is also one of the areas where we've set up pitfall monitoring. Here we have 10 pitfall traps spaced 10 metres apart with a mixture of glycol in them. These are used to attract invertebrates into them so that we can count the biodiversity of these species and use this as a baseline for ecosystem recovery after the eradication. The Castaway Depot was placed here to provision sailors shipwrecked on the island in the past. It was also where mice were first detected on the island in 1909. Today, we're using the Castaway Depot as a makeshift laboratory where we can perform our autopsies on dead mice to ensure 100% bait uptake of the bait marker that we've spread across the island. We're also using this laboratory to collect samples across the entire food chain to analyse the community dynamics of the island. By sampling plants, insects and animals, we can look at the ratio of isotopes of carbon and nitrogen in these different specimens. These ratios give an indication of how far up a food chain an individual is, as well as how much marine influence there is in its diet. We can use these to reconstruct the food web of the island and use this to predict changes that will occur after eradication of mice. This is the captive facility where we've been keeping parakeets on the island. We've been going around the area where we spread the biomarker and capturing as many parakeets as possible, which we predict may be vulnerable to the eradication methods proposed for mice on the island. By capturing as many of the 2 species of parakeets as possible, we take measurements from them which can be used for features such as predicting the sexes of them, as well as confirming if any bait has been consumed, for which we've found no signs so far. A selection of the healthiest parakeets were then placed in these cages and used to test how well they respond to captivity. A number of parakeet species are already kept in captivity on the mainland, so we don't predict any major effects of this. The parakeets were kept in the facility for 10 days and then we released them to make sure they could return to the environment normally. This was undertaken to ensure, if necessary, a backup population of parakeets could be established during the eradication and released afterwards to restock the island.